Everyone, my name is Bao Minh Tran and my student ID is 5030997. This is my HD test submission, which is analyzing YouTube video data from news publisher. More specifically, is to perform sentiment analysis. So my topic is tariff, and here are the channels that I use to extract the videos, and here are the keywords that I use to collect the videos and the start and end dates as well. So this is to load some technical thing. This one is to get a channel information. This one is getting the videos from each channel and its corresponding information, and to collect the comments for each video and clean the data. What I did here is to reformat a video title so I can clear punctuation, digits, and convert to lowercase to guarantee the consistency of the titles, and convert it back to the CSV file. I do the same thing with the comment text here, and I also drop the duplicated rows and drop the missing comments, like the comments with no values. And to remove the comments that are not in English, and also get rid of the common words but not like important, for example like a or the, something like that. This one is to extract the videos, collect the videos, comments, and also clean the data. So this is to import the libraries. So here I do some preparations with the date time and convert the duration of a video to seconds, merging these two data frames for further usage. And these are two functions to get the sentiment score for a given text. I used a text plot from the text plot library, and this one does the same thing with the functions here. However, it will classify the text, whether it's neutral, positive, or negative, instead of return a specific value. So this is my task. Is to use regressions analysis with visualizations to evaluate the following hypotheses. So just to sum up, the hypotheses are about comparing between average sentiment score of the comments on each video with their the sentiment of the video title for hypothesis 1, the total likes, and the duration of a video. So firstly, to avoid any accidental modifications to original dataset, I duplicate the data frame and save it to a new data frame. And also in that data frame we have various columns with plenty of information, but they're all redundant, so I only extract those are necessary for my task. And here I add new columns, the title get sentiment score, apply the get sentiment score functions above to the video title to get a sentiment score for each title, and also to classify those titles here. And I'll do the same thing with a comment text as well, create new columns and apply these two functions to the comment text columns. This line is used to create a subplot for my visualizations. And in order to evaluate the hypothesis, I have to prepare some data and plot it. So to prepare that, I group the data frame by the video ID, and for the first hypothesis I have to compare between the comment sentiment score and the title sentiment score. So I just get these two columns and calculate the mean values of the columns with respect to video ID, and I apply the regplot method from Seaborn library. This method supports plotting regression line as well as the scatter plot in one figure. So here just to polish the figure. And for the I'll do the same thing for hypothesis 2. Unlike the first hypothesis, in the hypothesis 2 I have to compare between the total likes and the comment sentiment score, so I extract only two columns. calculate the mean and plot it out. The same thing with the hypothesis 3, durations and common sentiment score. Calculate the mean and plot the the relationship. So these two lines is used to display the correlations coefficient matrix between 4 features here: title, sentiment score, common sentiment score, total likes, and durations of a video, and print it out. And these lines are used to polish the figures. So for the analysis, looking at this correlation coefficient matrix, we can see that there's no linear relationships between these 4 features, because here the value is really small, like only 0.09 or 0.02 here, very small to have any specific impact on each other. So we can see the same thing in the red regression line here. They are almost flat, so it means that there's no obvious relationship between each pair of features. So we can, however, give some insights about the data points. A very fascinating point here is that we can see that most of our videos lie on this horizontal line, the 0, which is like neutral. So it means that our news publisher, they were trying their best to publish the content with their title as neutral as possible, so that they can get the public opinion without heavily impacting how they think about the issue. So that's a good point. However, there's still some outliers, like some video with a really positive title, and of course getting some positive comments, but there's some not really like very negative video. But yeah, so for the next one, we can see that here most of our videos receive like below 10,000 likes, not quite big number. So that means that people do care about the topic, but they don't really give much attention of this. However, there's still some outliers I hear, like the viral content with 20,000 likes but receive very negative comments, or this one is nearly 60,000 likes and people are positive about the problem. Okay, so for the third subplot, we can see that here the regression line looks a bit down, but actually it doesn't have any thing to say about it, like maybe because we have like a bit correlation, but not that much to consider. So but we can see that the duration of a video usually between 0 and 1,000 seconds, which are considered to be short to medium video, I mean like in terms of duration. So it also implies an underlying trend of people recently, that people usually prefer to consume short videos, like we can see it from TikTok, or even though YouTube and Facebook now they have YouTube Reels and Facebook Reels, which aim to these customer segmentation. They love to watch the short videos. So even though they make short to medium videos, they still gain a lot of public attractions. So yeah, we can see one recent trend of the world today. So I think that's all for the analysis. For the problems and challenges, so admittedly I haven't faced any major obstacles while working on this task. I think the trouble was to deal with the polishing the figures, because you can see that there's so many methods and attributes to make our figures more visually appealing. So I have to read online documentations, and as well as one interesting thing about this is like before getting the result, I expected the data, the trains to behave differently, but it turned out that they behave differently from what I thought. So I think that's kind of really interesting point of the analysis. So that's all for my presentation. Thank you for your listening.